Welcome to lesson 3.1. 3.1 is dealing with fractions. So we're going to be working with how to convert fractions to decimals. The objective of this lesson, this lesson is going to be actually quite long because I have to keep going back to grade 6 stuff, and I have to make sure that you understand some of the concepts that we've already done, and some of you need a review. So sometimes I'll be flipping back and forth between grade 6 and grade 7 material to help you understand what we're doing. So let's get started. You can read the objectives there if you wish. We're going to start with just a basic introduction of what a fraction is and how fractions can be written. This is again going back to grade 6. If you take a look at this box here, you'll notice that I've got a box with 6 squares in it, all the same size. So there are 3 that are shaded and 3 that are not. So they are basically 3 out of 6 boxes shaded. So as a fraction, this is 3 over 6. Now we can reduce 3 over 6, if you remember, by finding a number that divides into the numerator, the top number, and the denominator, the bottom number. It has to be divisible by that number, and that number in this case is a 3. 3 divided by 3 is 1, 6 divided by 3 is a 2, and it kind of makes sense because if you take a look at that box, 3 out of the 6 squares, half of them are shaded, so this reduces to 1/2. You think about this as a decimal, 0.5 of the boxes are shaded. Now, how do I get 0.5? That is actually 1 divided by 2. As a percent, you can look up here, since half of it is shaded, 50% of it is shaded. Okay? So you can see fractions, decimals, and percents are all just different ways of expressing the same number. The amounts, 50%, is equal to 1/2. That is equal to 0.5. Now normally you don't put more than one equal sign in something like that because you can't have an equation with 2 equal signs, but this shows you that these 3 things are exactly the same thing. So since we know they're all the same thing, our next goal is to get you, the student, to be able to go from any one of these given to you to any of the others. So if I give you 50%, I want you to be able to get to 1/2 or to 0.5. If I gave you 0.5, I want you to be able to get to 1/2 or to 50%. And of course, the final one, if I give you 1/2, I need you to get to 50% or to 0.5. So there's 6 things you have to be able to learn in this lesson to help you out in the future. So let's take a look at the first one. Let's start with the parts of the fraction so that when I'm working with these words that you understand what I'm doing. First off, the top of the fraction, the 1, this is called the numerator. The bottom is referred to as the denominator. This 1/2 is referred to as a simple fraction or a basic fraction because we have a numerator and the denominator. The numerator is actually less than the denominator. It's what we normally would write down if someone said write down a fraction. Now we also can have a fraction which is called a mixed fraction. And in a mixed fraction, what you're going to do is you're going to put together 2 different parts. You're going to have a fraction, the 1/2, so this is my numerator, nothing's changed here. Okay. And we have a denominator. Nothing's changed there. But out front, we have what's called the whole number. Now this is called a mixed fraction because it's a mixture of a fraction and a whole number. Okay? And we're going to teach you a little bit more how to manipulate that later. So our first step is, now that you know what the pieces are called, let's go and start converting fractions to decimals. A fraction is another way of writing a divide question. And I've shown you this before. If you think of a divide sign, it looks like this, right? There's a big fancy divide sign. A fraction is nothing more than a divide sign with the numbers in. So if you want to figure out how to get a fraction to a decimal, you divide. Top divided by bottom, the numerator divided by the denominator. Okay? So a fraction is another way of writing a divide question. Okay? So this is 3 divided by 6. Okay. We can easily calculate that on your calculator to be 0.5. On your calculator, you would put in 3 divided by 6 and press equals. So the general rule to convert a fraction to a decimal is to divide the numerator, which is the top, by the denominator, which is the bottom. Now, because you're using your calculator, and because the answers are in the back of your textbook, you have to show me what you did. So a lot of cases, this is always going to be what you did, what you got. So for the first one, I've got 3 over 8. To convert 3 over 8 into a decimal, you're going to take 3 and you're going to divide it by 8. And on your calculator, you're going to put, and I'll just pull my calculator up here. I'll pull a calculator. Okay, so you're going to take 3 divided by 8. So you're going to press, pull it back up. Where'd it go? Here we go. 3 divided by 8, and you're going to press equals. And you're going to get 0.375. Okay? All right. Now, 6 divided by 8 is the same thing. 6 divided by 8, and when you put that in your calculator, you're going to get 0.75. For 4 over 5, same thing. 4 divided by 5, you put it in your calculator, and you're going to get 0.8. Okay? Now, you may have noticed that these decimals all end. There's nothing after the 5 unless you want to start thinking of putting in zeros. There's nothing there. It terminates. That's what the term is. It ends. There's no more numbers after it, no more digits after it. But if you try 1 over 3, you'll notice something changes. If you go 1 divided by 3 on your calculator, look what takes place. Oh, that ain't going to work. 1 divided by 3 equals, look at that, 0.3333333333. And you'll notice it just goes on and on. Now, if my calculator screen showed even more numbers here, they would all be 3s. It goes on forever. It never changes. This is referred to as a repeating decimal. Okay? So, this becomes 0.333333, and it doesn't stop. So if you had enough paper, you could keep doing this for hours, and you would never ever get to the end of the 3. It goes on for infinity. It's an infinite number. It just keeps repeating and repeating and repeating. So this decimal does not stop. It repeats forever. Because it repeats forever, it's impossible for us to write it down as a decimal. So we have to have some way of writing down that it goes on forever to tell people that. Okay? So to do that, we're going to have to first identify the part that repeats. And that repeating part is called a period. Now in our numbers, if you look here, the period in this, the part that repeats is the 3. Okay? You want to locate the smallest part that repeats. So don't put down that it's 3 repeating or 3 repeating. The number that repeats is a 3. So what we're going to do to show that that is the part that repeats is you're going to put a bar over top of just that 3. So to write the decimal equivalent of 1 over 3, you would write 0.3 and put a bar or a line right above the 3. It's very important that it's just above the 3. Don't put it anywhere else. It can't be above the 0, it can't be above the decimal, and it can't extend past it. Because you want to show that just this number here, this digit 3, is the only thing that repeats. So, if I was writing this down and had to say it to somebody, this would be referred to as 0.3 repeating. So this is how I would say it. 0.3 repeating. Okay, now 2 over 11. To do 2 over 11, grab your calculator and calculate and write down what 2 over 11 is. So 2 divided by 11, write down what you did and what you got. And you'll notice that your calculator is going 0.1818181818. Now on some calculator screens, your screen only goes to a certain point. So you may have something like this, and you may see this. Now, this does not mean that the last digit is a 2. What this means is your calculator is taking the 1 that's here and the 8 and the 1/8, which goes on forever. It's rounding it off and saying that since this is 5 or greater, the 8's 5 or greater, that this 1 becomes a 2. So your calculator is rounding it off. So depending on your calculator, it may look like it stops repeating because there's a 2 there. So if you have a calculator that does that, you have to be aware of this. The period is 18. So to write this as a decimal equivalent, it is 0.18, and the bar must go over just the 1 and the 8. It cannot go anywhere else. There is a difference between this. If you have the bar over the 1 and the 8, this decimal equivalent looks like this. If you have it only over the 8, this decimal equivalent looks like this. All right? And you cannot put it over just the 1 because it's just that you can't have 0.111118. It just doesn't work. All right? So you can see that because this has to be over, you're trying to represent 181818, which is the 18 is your period, you have to make sure that you repeat only, put the bar only over top of that actual 1 and the 8. So this would be said as 0.18 repeating. Okay? Let's go to the next one. So here's one for you to do. Pause the recording and do this example. Okay, so we have 7 over 9. What you did, 7 divided by 9, 0.7777, and it goes on forever. The period is the 7, so the decimal equivalent is 0.7 with the bar over just the 7, and this is said as 0.7 repeating. Okay? Any questions on? Well, you can answer questions. Sorry. All right. 2 over 7. Do that one. Pause the recording. Okay. So, going on to this one. This is 2 divided by 7. And that's equal to 0.285714, 285714, 285714. Now this one is a challenge because your calculator only shows probably 10 digits. So you may only get like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You may get to somewhere around here or even here, and your calculator might even round that. So you have to take a look at this. And look, it goes 285714, 285714. Now you have to look at your calculator to find out what's going on. Now here's the thing. If it's a fraction and you have a number which goes on like this, it will repeat. Okay? It has to repeat. It's the definition of a rational number. So it's clear in this case that the period is 285714. So as a decimal equivalent, you're going to put the 285714 and put the bar over the 285714, all of it. Now, how do I write this down? This is 0.285714 repeating. That's how you would say it. Okay? Now, let's take a look at the next part of this. What happens when you have a number in front of the fraction you're trying to convert to a decimal? Like, for example, if you take a look here, we just have 2 over 7. Well, 2 over 7 is simply 2 divided by 7. But what happens if I have something like 1 and 3/4? The key here to understand is that the fraction is the 3/4. And since we're converting a fraction to a decimal, you're going to convert just the 3/4 into a decimal. So this is the conversion that you're doing. So to do that, you take the 3 divided by 4, just like we did before. You're going to get 0.75. Now don't forget that the question was 1 and 3/4, not just 3/4. So you have to come and put that 1 back in here. So your answer becomes the 1 in front of the decimal part, 0.75. So your answer is 1.75. So how does this look? Well, let's take a look at the question. I've got 12 and 5/18. First thing I have to do is to convert the fraction 5/18 into a decimal. To do that, I'm going to do like we normally did, 5 divided by 18. You're going to grab your calculator. You're going to go 5 divided by 18, and that is 0.2777. It goes on like that. All right? Now the period in this case, the part that repeats, is the 7. So the decimal equivalent, just the decimal, is going to be 0.27 with the bar over the 7. Right? Now don't forget we have a whole number there. That whole number is a 12. This 12 has to come back and take its place in front of the decimal. So you end up with 12.27, where the 7 is the repeating. Now, how is this stated? Well, we have to make sure that we only have the 7 repeating. So we have to add a word in here between the 2 and the 7. And that word is the word with. This is said as 12.2 with 7 repeating. We can't say 12.27 repeating because that would look like this. This is 12.27 repeating. So we have to make sure that we change this in such a way that only the 7 is the repeating. So this becomes 12.2 with 7 repeating. All right, turn the page. Here's another example. All right, so let's have you try this one. Pause the recording and take a crack at it. Okay, so first, convert the fraction 8/9 into a decimal, showing what you did and what you got. In this case, it's 0.88888888. And it goes on. The period is the 8. So the decimal equivalent is going to be 0.8 with the bar over the 8. Now, add in the 4 because we had the 4 at the beginning. So this is what we've got, 4.8. So this one is 4.8 repeating. Now, if you put in 4 with 8 repeating, it wouldn't be wrong. But because there's no need to separate the repeating portion right here from a number in front of it, it's just 4.8 repeating. Okay? Now, if the decimals do not end or repeat, or you can't tell, we know they always repeat, but if you can't tell, then you can actually take and you can round them. Okay? So let's take a look at 5/17. We've got 5 divided by 17, which is 0.29411761, and it gets messy. So in this point, we don't know if it repeats. I can tell you from just mathematical point that it does repeat, but we don't know what the period is. It's too big. So what we're going to do in this case is we're just simply going to take and round it off. Okay. Now let's go back to some simple rounding rules. Okay. Remember that when you're rounding a number, and I'll take 0.24. Let's do 294. 294. And if I want to round it off to here, this is my cutoff. Does the 4 cause the 9 to go up or to stay the same? Now, because 4 is less than 5, the 0.29 stays as 0.29. It doesn't change. All right. Now, if this was 0.367, and we were rounding it off here, this 7 would cause the 6 to go up 1. So this would become 0.37 because the 7 is 5 or greater. Okay? So if you don't know or you can't tell, you have to round it off. So let's do some rounding exercises here. I've got 5/87, and I want you to convert it to its decimal equivalent, and then I want you to round it to the nearest thousand. So you try that, pause the recording. All right, first thing, 5 divided by 87, that is 0.05747126444, and we don't know what's going on here. All right, big number. So I need to round this to the nearest thousandth. Now remember, this is a TH, so thousandths, if you don't remember, this one here is the tenths, this one's the hundredths, and this one's the thousandths. So what I want to do in this case is I want to cut it off here because I'm asked for thousandths, and I'm going to take a look at this number right there to find out whether this number causes that number to go up or stay the same. So let's take a look over here at our example. Our tenths, hundredths, thousandths, so there's my cutoff. So I want to know, does this 7 change because of the 4? Well, the 4 is not 5 or greater, so what's going to happen is the 0.057 is going to just stay like that. If that was not a 4, if this number was like an 8, this would change to be 0.058, okay? Let's go to the next question. All right. Now, let's talk skill review, reducing fractions to the lowest form. If you have any trouble with rounding, go back and review rounding or come and talk to me, okay? Our next skill we have to review is reducing fractions to the lowest form. Now, to reduce a fraction, you have to find a number that goes into both the top and the bottom, the numerator and the denominator. It's the same number, and it's got to divide in evenly. The easiest thing to do is to take a look at 24 over 72, and since they're both even numbers, start with 2's. 24 divided by 2 is 12. 72 divided by 2 is 36. And now look for another number. And you want to keep repeating this until you get down to a number that has no way to get any lower. So you may look at these and go, hey, wait a minute, 6 goes into both of those, so you can do 6. 12 divided by 6 is 2. 36 divided by 6 is 6. Now what goes into both 2 and 6? Well, a 2 does. And that gives you 1/3. Now this is the manual way of reducing fractions. This is from grade 6. So you have to know this because when we convert from a decimal to a fraction, you're going to have to do some reducing. So let's look. Now that you know how to go from a fraction to a decimal, let's go from a decimal to a fraction. Now just as a quick review, we know there's 2 out of 4 boxes here. So that means that this is 1/2. And 1/2 is another way of writing 0.5 and 50%. So what we're going to do now is we're going to try to get you to get from this 0.5 to 1/2. So how do we do that? Well, you have to know your place values. Remember we did a couple of minutes ago, all right? This is my tenths. This is my hundredths. This is my thousandths. And of course, if you had to go further, this would be 10,000ths, okay? The first thing you want to look at when you're trying to convert a decimal to a fraction is the place value of the last digit in your decimal. In this case, we only have one. It's in the tenths place. Because it's in the tenths place, that tenths means that your denominator is going to be 10. The 5 just slides over, and now you have to reduce this. What goes into both a 5 and a 10? Actually, in this case, a 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. And of course, we know that 0.5 is actually 1/2, so we know we've done it correctly. Okay? So what if there's more than one digit here? What if this 5 wasn't the last one? What if there was more digits here and here? Well, in that case, you're just going to go over here, and your denominator is going to change. If there's 2 digits, you're going to have 100. If it's 3 digits, you're going to have 1,000 in your denominator. So let's take a look at a question. 0.25 into a fraction. Well, I'm going to give you a shortcut, and then we'll go back and do it the other way. If you remember back in grade 6, you can read fractions. This is referred to as 25 hundredths. Now, if this does not make sense to you, just look at the last digit. It's a 5. It's in the hundredths place. So if you don't know how to read a fraction because you've forgotten, it's not a big deal. Just look at what place value the 5 is in. The 5 is in the hundreds place. This means that that denominator is going to be 100. The decimal part becomes your numerator, so your numerator is going to be 25. So what does this look like when you do it? Well, the 5 is in the hundreds place, so that means this is 100. The 25 is your decimal, so that becomes your numerator. And now you have to reduce this. You can divide both of these by 25. 25 divided by 25 is 1. 100 divided by 25 is 4, so you get 1/4. All right? Now let's take a look at the next example. 0.125. Now remember before I showed you these boxes. Okay? This is the tenths, this is the hundredths, this is the thousandths place. Okay? Now you've got 0.125. Now, because the 5, the last digit, is in the thousands place, that means that your denominator is going to be 1,000. So look at the last digit. This is in the thousands place. So the denominator is going to have to be 1,000. The numerator is the decimal portion of the number, so the numerator in this case is going to be 125. So write this down and reduce it. So you're going to have 0.125. This is in the thousands place. This here is 125. So now you have to reduce this. Now, if you can't remember how to reduce, find a number that goes into 125 and 1,000. In this case, I know that anything divisible by a 5 ends in a 5 or a 0, so I can divide both of these by a 5. 125 divided by 5 is actually 25. And 1,000 divided by 5 is 200. And since they both end in a 5 or a 0, I can do this again. 25 divided by 5 is a 5. 200 divided by 5 is 40. Now I can still go by 5 again. 5 divided by 5 is 1. 40 divided by 5 is 8. So you get 1/8. Now if you're not sure whether you did this correctly, just do a quick check. Go 1 divided by 8. You should get 0.125. If your final reduced fraction does not give you what you started with, then you made a mistake somewhere and you have to go back and try and find it. All right? So sometimes the decimal also has a whole number. Now when we did the fraction part, we ignored the whole number for a second and brought it back at the end. We're going to do the same thing here. So 3.65 is my question. I want to convert that to a fraction. Remember, we're doing a decimal to a fraction, so the decimal is actually the 0.65. The 3 we will leave until later. So this is what I'm working with, 0.65. Now the 5 is in the hundreds place. The 65 is my decimal portion. That becomes my numerator. And now I have to divide or simplify this. Now, if you do this, you go 65, you can divide this by 5 and divide this by 5, and you will end up getting 13/20. So that is your fraction from the 0.65. So now don't forget that the question wasn't 0.65, the question was actually 3.65, so bring the 3 down and put it in front of your fraction. So 3.65 is 3 13/20. Okay, so let's have you go down and try this one right here, 34.2. Pause the equation and do this question. Pause the equation, pause the video. Okay, so we're going to be converting 34.2. Remember, we don't use this at the beginning. We're going to work with just the 0.2. This is in the tenths place. That means your denominator is 10. The 2 becomes your numerator. You can divide both of these by 2 to reduce them. 2 divided by 2 is 1. 10 divided by 2 is 5. Now don't forget, we had a 34 here, so your final answer is going to have to include the 34. All right? So reducing gives you 1/5. Combining with the 34 gives you 34 1/5. All right, turn the page. Now, what happens when you have a repeating decimal? Well, nothing really changes. We're going to take Oh, sorry, this is repeating decimals. When we want to convert a repeating decimal to a fraction, we have a problem. Because if you think about what we were trying to do before, I had to find the last digit in order to find the denominator, didn't I? Well, these don't stop. They go on forever. So I can never find that last digit. So we have to find a different way of doing this. Fortunately, we know that if we use a 9, that it will work. So what I would like you to do on your calculator is I'd like you to go and divide 7 by 9. When you did that, 7 divided by 9, you should have seen 0.7777777. There's a possibility that your last digit might be an 8, but it's very clear that 7 repeating is the decimal for 7 over 9. Now look, there's one digit in the period here, that's a 7, and there's one single 9 here. So this is the rule you have to use. Identify the period. Once you know what the period is, you put a 9 down for every digit that's in the period. So for example, 0.35, the period has 2 digits in it, a 3 and a 5. That means you're going to have a 99 on the bottom. 1 9 for the 3 and 1 9 for the 5. Of course, the 35 comes and stays there. Now 35 over 99, find out if it works. Take 35, divide it by 99, and see what you get. And you will see 0.353535. So your answer looks like that, 0.35. All right? Want you to try the one on the bottom here. Well, actually, I'll help you with this one. Okay? Now, we're going to do 30.012. Now remember, we're going to do just the decimal part first. Ignore the 30 for now. So I have 1, 2, 3 digits, which are repeating. That means my denominator is going to have 1, 2, 3 digits, which are 9. Now remember, this only works for repeating decimals. If it's not a repeating decimal, then you have to use 10, 100, or 1,000. All right? Now 0, 1, 2, if you want to put 0, 1, 2 down, you can. Remember that a 0 that's in front of a number doesn't change anything, so it can disappear, leaving you with just 12. So now you have to reduce 12 over 999. And they're both divisible by 3, actually. So that gives you 4 over 333. And now, bring your 30 in. So your answer is 30 and 4 over 333. All right? Turn the page. The last thing in this lesson is changing a denominator to a specific denominator of 10, 100, or 1,000. This is something we did in grade 6, and I don't know if you can recognize this, but this is the way it works. You need to find how to get 11/20ths to have a denominator of 100, but you can't change it to be a different number. So if you remember when we were doing equivalent fractions, as long as you multiply the top number and the bottom number by the same number, right? So if you multiply the denominator and the numerator by the same number, it doesn't change. I'll give you a quick example. If I multiply this 1/2, if I multiply the top, 1 times 2, I get 2. If I multiply the bottom, I get 4. 1 is half of 2, and 2 is half of 4, so these are still 1/2, or 0.5, or 50%. They're all the same thing. But the only way they stay the same is because I multiplied the top and the bottom by the same number. So your goal is to try to find a number which will multiply the 20 and get to 100. So you have to do some work. If you're not sure, you can take 100 and divide it by 20, and it'll get you the number 5. So if I multiply 20 by 5 to get 100, then 11 times 5 gives me 55. So there's your answer, 55 over 100. You don't have to reduce it because the goal was to get it as a number over 100. Okay, so creating an equivalent fraction means changing the numerator and the denominator by the same action, by multiplying by 5. This gave me my denominator of 100. Okay, the numerator stayed as 55. So the box should have a 55 in it. Let's take a look at the next one here. The key question here, back up here, is to ask yourself, how do you get from a 20 to the 100? That's the key question, because once you know how to do that, you multiply by 5, you just do that to the top and the bottom. So let's take a look at another one here. All right. I want to convert 1 over 5 to have a denominator of 10. Okay, so I know my denominator is supposed to be 10. How do I know it's supposed to be 10? It says right there, denominator of 10. To start this, what do you need to multiply the denominator by, this 5, to get 10? Well, in this case, we're going to multiply it by 2, right? Now remember, when you make an equivalent fraction, you have to multiply the top and the bottom by the same number. So this has to multiply the top by 2 also. So 1 times 2 gives you 2. So the box has to contain a 2. So my fraction is 2/10. Okay? So to do this, then do this to the numerator. I forgot this part up here. Numerator and the denominator. We're talking about multiplying. Denominator. My spelling is getting worse. Okay? Let's take a look at the next one. I want you to convert 9 over 200 to a denominator of 1,000. Try that, please. Pause the recording and give it a whirl. Okay, so you're back. I need to get 9 over 200 to equal something over 1,000. I got the 1,000 from right here. So, how do I get from a 200 to 1,000? Well, if you're not sure how, just take and go like this. Divide 1,000 by 200. All right, that will get you 5. So I am multiplying by 5. Whatever I do to the top, I have to do to the bottom. So since 200 times 5 is 1,000, 9 times 5 is 45. There's my answer right there. Okay? Let's try a different question. How about 1/4? I want you to change that to be with the denominator of 100. So pause the recording and try that one. Okay. How do you get from 4 to 100? In this case, you're multiplying by 25. If you're not sure, go 100 divided by 4. That'll get you the 25. Now, whatever I do to the bottom, I have to do to the top. So 1 times 25 is 25, and you're done. Okay? Coming up in the assignment, they're going to give you a question like this. They're going to say 1 over 5. Or say, 1 over 5. Convert 1 over 5 to a fraction that has a denominator of 10, 100, or 1,000. When this happens, you have a choice. You can set this up to be a 10, a 100, or a 1,000. It's your choice. My advice is use the easiest one possible. How do you get from a 5 to a 10? That's the easiest one. Multiply by 2. So multiply this by 2. You get 2/10. Okay? So, if you have any questions, rewatch the video or come in and talk to me. And we will see you in the next lesson.